What's going on, guys? This is AK and welcome to your fourth and hopefully the final tutorial on periodic table. It's almost 6 and although I'm pumped up because of the last tutorial, we were discussing some really exciting things. I hope it's exciting for you too, and I hope you don't have any problems understanding it. You can go over the tutorial again if you don't really understand it the first time, and please feel free to contact your teachers or me, or both Karan and me. We'll be more than happy to help you guys out. Alright guys, now before I move on, there were a couple of things that I wanted to discuss with you guys, since you feel that it's not being covered. Uh, there are a couple of statements I'll tell you. Uh, Electron affinity is a measure of the tendency of the element to form an anion, or ionization potential is a measure of the tendency of an element to form a cation. Now, guys, this is really simple, and these are really genuine and general statements. I don't really think you would be having problems understanding them, but still, if you guys need clarity, um, as you've already discussed in ionization potential, um, you're supplying energy, or the atom is absorbing energy, and therefore an electron is getting ejected out of the last atom, beg your pardon, the valence shell of the atom, and therefore acquiring a positive charge. Therefore, ionization potential is a measure of the tendency of the element to form a cation, since positive charge represents a cation, and so the statements hold true. Uh, Again, in the similarly in electronic, I'm so sorry, in electron affinity, uh, when the atom releases the energy and begins to when it releases the energy and acquires a negative charge by gaining an electron, again the negative charge indicates the anion, and so electron affinity is a measure of the tendency of the element to form an anion. So I hope you understand these concepts. And one more thing, that an anion is always larger than its parent atom. Now by parent atom we mean, like if you have an atom and if it loses electrons, so let me write minus electron, which means it loses electron, so it'll form uh, an A plus ion, which is an A plus cation. And if, for example, A gains an electron, so in this case, I just said that if the parent atom, which is A here, let me write it down. This is the parent atom, guys. Right. Let me change my color. Alright. This will form an A minus. Right. So an A minus, guys, will always have an additional electron, whereas an A plus will always have a deficit of an electron. Now, because of this deficit, the internuclear, no, I'm really sorry, the effective nuclear force of attraction between the nucleus and the electron, that is, will increase, guys, and so the atomic radius will decrease. Let me write AR as atomic radius. However, here as the electron increases, the atomic radius again will increase, and therefore an anion, guys, which is a negative ion, is always larger than the parent atom, and a cation, guys, is always, the size of a cation, guys, is always less than the parent atom. Now that's pretty much the concept which you will be coming through in the textbooks. Now I think I guess it's time to move on to the next portion, which is electronegativity. Yeah, in electronegativity, if you're using Anita Prabhat, I don't know if they've corrected it this year, but otherwise, in other books like Frank, if you're using Frank, I think they have the correct definition. The correct definition, guys, is electronegativity is the tendency. Please note it, guys, because it's wrong in most of the books that I've come through. So we say that electronegativity, let me just indicate it as En. It is the tendency, guys, it's the tendency of an atom attract. Now, this is where the trick part comes in. A shared pair of electrons to itself sorry, to itself when combined in a when combined, this is really important guys, in a covalent, remember it's always covalent compound. Now I'm pretty sure your teachers must have corrected the definition if it's not correct, but this guys is the correct definition. The portions that are in red are the ones that the books usually get wrong, or basically ICSE demands these correct words in your paper. So I'm gonna go through it again, and then I'm gonna explain to you the real meaning behind it. So basically, electronegativity is the tendency of an atom, guys, to attract a shared pair of electrons to itself, to that atom, when combined in a covalent compound. So as the definition suggests, that an atom is basically attracting a shared pair of electrons to itself when it is in combination with a covalent compound. Now, guys, in books, I don't know if it's there in your book or not, but covalent bonds have been explained in the bonding chapter. If you wanna go through them, you can. But covalent bonds are of two types, guys. First one being the polar covalent compound. Alright guys, what I have for you here is the next subtopic, which is dealing with covalent bonds. Now guys, we have two types of covalent bonds, polar covalent bonds and non-polar covalent bonds. So polar covalent bonds are the easier, I'm really sorry, is the tricky bit, and non-polar covalent bonds are the easier bit. So here, as you can see, a hydrogen atom and a chlorine atom, as you already know, form a covalent bond, and therefore this hydrogen shares this electron with chlorine, and chlorine shares this electron with hydrogen. This way, hydrogen completes its duplet and chlorine completes its octet. However, in this covalent combination, guys, this electron of hydrogen gets attracted towards the chlorine atom, thereby giving this chlorine atom a negative charge and this hydrogen atom a positive charge. Now that's all in polar covalent compounds. This is the only bit that was a bit tricky, a bit not easy to understand, and if you have understood this in the first try, then you do deserve a pat on your back. So now that's pretty much it in polar covalent compounds. Again, I'm going to just recapitulate that this H and this Cl will form a covalent compound. However, due to the difference in electronegativity, this electron of hydrogen will get attracted towards this Cl atom, thereby giving Cl a negative charge and hydrogen a positive charge. Now here on non-polar covalent bonds, this is really simple because a shared pair of electrons in this case lie exactly midway between the two atoms in the covalent combination. Okay guys, we're done with the understanding part in electronegativity. However, there are a couple more things that you need to understand. You already know about electrovalent and covalent compounds, and if you don't, then please refer to our chemical bonding tutorial. Alright guys, so if the two atoms that are let them be X and Y, that are that are gonna bond, if the electronegativity of this is say 2.2 and y is say 6.9. Now the difference between the electronegativities, or let this be 7.9. Now the difference between the electronegativities here is considered to be high, and so this is another way where you can distinguish the kind of bond that will actually occur between these two elements. Because if the electronegativity is quite high, then the bond that takes place or that happens, or the kind of bond, I'm really sorry, that X and Y have in between them is ionic bond. And if the electronegativity is quite low, guys, then the bond formation that takes place between X and Y is covalent. Now guys, this is an extremely important subtopic again, and you guys must keep this in mind. Uh, the last thing that remains in electronegativity is again um, the only portion left now is on variation of electronegativity and metallic and non-metallic character. Once again, if you want me to recapitulate, and guys, please understand that these values are just taken. I don't even know. I don't think 7.9 electronegativity exists. But just to tell you that if the electronegativity, oh sorry, this should be difference in electronegativity. If it is high, then the bond formation between X and Y, the two bonding atoms, is ionic always. And if the difference in electronegativity is low, guys, the bond formation is covalent. Alright guys, now the only portion that's left in electronegativity is the variation across a period around the group. Now again, it's pretty easy. Like ionization potential and electron affinity, electronegativity increases across a period. And why? The reason is that as we go across a period, the atomic size decreases and the effective nuclear charge increases, thereby the effective nuclear force of attraction being really strong between the electrons in the nucleus, and therefore the attraction or the ability of the atom to attract a shared pair of electrons increases, guys, and therefore electronegativity across a period increases. Same way, electron negativity down the group, guys, as the size of the atom will increase, the shells will get separated out, the effective nuclear charge of the nucleus on the valence electron will decrease, and therefore the ability of the atom to attract any shared pair of electrons in a covalent bond formation will decrease, guys. So that's pretty much it. And if you're using Anita Prasad, it also gives you uh, variation, apart from variation in periodic table, as you know that as we move from left to right, guys, the metallic character decreases. For instance, if you have sodium here, then you'll have chlorine here, and so you can see that chlorine is a non-metal whereas sodium is a metal. Same way, if we have sodium here, we have cesium here, and right here the metallic character increases, guys, because cesium, this is cesium, guys, and this is chlorine, so don't confuse this. I'm gonna write it again, small e. This is cesium, this is sodium, and metallic character, guys, it increases, whereas metallic character this way, it decreases. And vice versa is also true for non-metallic character. For instance, if you go across a period, then non-metallic character increases, and if you go down the group, then the non-metallic character, it decreases, guys. I hope you've understood this because it's really easy. Um, whichever book you're referring to, I'm pretty sure it's a good book since you're studying in a very reputed school. That's pretty much it. If your book has anything more related to this, or if you have doubts on anything else, please feel free to contact us. So that's pretty much it. Once again, just a recapitulation. Across a period, the metallic character decreases, for example Na here and Cl here, and down the group, guys, the metallic character increases, Na here and cesium. Oh, I'm really sorry, Ce is not the right symbol for cesium, it's Cs, guys. That's my mistake. Alright, guys. So, yeah, as I was saying, metallic character increases down the group, and non-metallic character decreases down the group. Metallic character increases across the period from left to right, and non-metallic character increases left to right. The only thing that's left is, I think, the group 1 and group 17, which is pretty easy. Most of it is just for you to note, so I think it'll be easy for you if you just cram it up, you will read it. Just chill, guys, this is easy. And guys, so we'll meet soon again. We come up with something better. Me and my partner signing off for now. Thanks very much for watching.